Hello, welcome again. We are solving some questions of machine design. The topic is friction in screw, bearing and clutches. Question number 18 is a multi-plate disc clutch transmits 55 kilowatt of power at 1800 rpm. Coefficient of friction for the friction surfaces is 0. 0.1. Axial intensity of pressure is not to exceed 160 kilonewton per meter square. The internal radius is 80 mm and zero point 0.7 times of external radius. The number of plates needed to transmit the required torque: option A 11, option B 12, option C 10, option D 13. So here the pressure is maximum pressure is given because pressure is not required to exceed 160 kilometer per meter square. So that is maximum pressure. So maximum pressure is 160 newton for 3 newton per meter square. Okay, and inner radius is given as 0.08 meter or 80 mm. And the ratio of outer radius and inner radius is also given. The internal radius is 80 mm and zero point 0.7 times of external radius. So from this we can find out external radius, that is your 0.08 by zero point 0.7, that is 0.1143 meters. Okay, and coefficient of friction is given as 0.1. 0.1, and power transmitted is your 55 kilowatt at 1800 rpm. Okay, rpm is 1800, power is 55 kilowatt. So as it is a clutch and the maximum pressure intensity is given, so we will not use uniform pressure theory because clutches are generally designed according to uniform wear theory. So if it is not given, okay, so now the maximum pressure intensity is given, so we will use uniform wear condition for designing that clutch. Okay, so in uniform wear theory, the load is given by 2 pi pi ri bracket r naught minus ri, where pi is your maximum pressure and maximum pressure will be at inner radius, because in uniform wear theory we assume that PR is constant, so P will be maximum when R is minimum. So R is minimum at inner radius. So that is Pi is your 160 into 10 power 3 and Ri is your inner radius 0.08, and these are the outer inner radii. So that is 0.1143 minus 0.08. So the force on the plate is your 2759 newton. So that is the force on a single plate. Okay, because we have taken only the single plate, so that is force on single plate. And the torque transmitted by the clutch is given as mu w r equivalent. So mu is coefficient of friction or w is your F that we have calculated, and r equivalent in case of uniform wear theory is r naught plus ri by 2. Okay, so now we can put these values. So that is your 26.78 newton meter. So that is the torque transmitted by a single surface. Okay, now the total torque is given by the total torque, sorry, power is given and rpm is given, so we can calculate torque. So total torque is your 298, power is 55 kilowatt and rpm is 1800. So that is torque capacity is 291.8 newton meter. Okay, so total torque capacity is 291.8 newton meter. This is the total torque capacity and this is the torque capacity by a single surface. Okay, so number of surfaces required are total torque divided by torque per surface. So number of surfaces are 10.9 or 11. Now in this question we have to determine number of plates required to transmit required torque. Okay, so number of surfaces are 11. So here we can see that if there are two plates, then there is one surface. Okay. If we add another plate, then there will be two surfaces and three plates. The formula for number of plates is m plus n minus 1. So number of surfaces is m plus n minus 1. Okay, that is equal to number of surfaces. So m is number of driving plates, okay, and n is number of driven plates. So number of plates comes out as m plus n is equal to 12. So answer is option D.